Welcome to another episode on my Raspberry Pi 2 running Ubuntu Linux and the robot operating system ROS. You can't see the Raspberry Pi itself. It is stacked under the serial Pi Plus, which is connected with a serial cable to the Minicom serial terminal on my computer, as well as a small band cable which is connected to this breadboard. And last time I tried to get problems solved with a new package, Mechatronics Pi. That didn't go without problem, and with everything that runs with it, well, as yet nothing runs with it. Everything here is still only controlling or controlled by the robot Pi package. Last time I ended with the problem that actually everything hardware wise worked except for this LED. If you have seen this series of videos before, then you may be familiar with the fact that I need a flashlight and then shine upon this fischertechnik phototransistor, press on this little button, then this small green LED will burn, and when I shine with the flashlight here, this red LED will start to go on and off. And first of all, the green LED didn't work, and then finally the red LED started to shine constantly, and that's a problem because it shouldn't. And now, when I was completely booted without running any program as yet, it just upon boot starts burning, which is not good either. So now I want to do two things. One is testing if when I run the robot Pi publisher and subscriber, everything returns to normal. If not, I have to check the value of the GPIO, because I want to know if the port to which the red LED is connected to is possibly broken. I hope not, but it might just be. So, and in order to test that, I have to disconnect the band cable, and I will do so on the end of the Raspberry Pi because that's much easier. Anyway, let's test for now just with the packages running and or the publisher and subscriber running and the electronics on this side. I have a nice light here. Is this sufficient? Well, let's just start publisher as well as the subscriber. And then I notice a little mistake. I forgot to start the ROS core, but that will be just fixed in a moment. It's running, so I can start the publisher. Starting the subscriber again. Well, with propeller you can clearly see it is working. This is a different story. There it goes. So with this one, let's see whatever happens. Pressing the button, maybe some delay. I hope that works out well. But alright, let's do this. Let's see. This one is connected to the voltage divider, and on the oscilloscope I can see that that works quite well. Then I can see on the oscilloscope that the button is pressed quite well, and the purple one is always on now because it always burns. The only thing I can't figure out is why the other LED doesn't work, so I move this one to, to what? Yeah, let's move this probe right here. And there I see that there is hardly anything happen in voltage wise on the green LED. So I need to check two things. The connection here and the value here. So let's check the GPIO.
So before I can do things, I need to download software, but one of the things that I notice now is that this propeller is still running despite that everything has been stopped. So I want to stop this manually. Look at the way Python is configured. Input RPI.GPIO as GPIO, and then GPIO.cleanup. Well, this really didn't happen regarding the fact that this is still running and this is still running. And of course I'm not going to talk about this one. So I opened a Python session and import RPIO GPIO as GPIO, exactly like I do here, and then GPIO cleanup. What will happen? Let's see. Alright. So it's cleaning up, but still burning, or still running, and still burning. No type of aspect. So I have to go to where? Well, this is our private script, and then I need to find out which is which. Then 18 is the LED, I think, most likely. Let me check schematics. So I have on 18 the red LED, which I have to put down then, and then I have a brown one, which is then, which is which. This is 18, this can't be, this should be 22 then. If I'm a bit confused. The red one is supposed to be 18. Let's count. The motor is 32 anyway. 32 and and then I think I made a little mistake, because this is set right. Gray is 32, then counting down is 30, 28, 26. And the red LED should be 18. So how can this be done there? That means that I have made a wiring mistake. So let's go back. That means that I have somehow made a wiring mistake here, so it could be alright anyway, and I'll have to check it thoroughly. So if this wire from the motor is correct, then the other one is in the wrong place. Ouch. Right, time to correct. Right, so all wires checked, which means that this one has been reconnected to 18. And this LED is out now. Question is, will these go out when I run the program again? Well, let's just take that. There's one. And there's one. And then, okay, these go out and on. Now let's check this one. Alright, the little red green LED works. Does this work? Immediately, yes. So this implies that there's nothing wrong with the GPIO. Which is a relief. So this means that I can actually get on with a new package and see if there's anything to do. And I can quit this Python shell and let's see if anything is going right here. So we go to Catkin workspace. I have the source set up. Then log in, and again something that is a relic of last time. Why doesn't this work? Somehow I've made a mistake. And how come? I can of course run Catkin Lake, that should be all, although the tutorial said Catkin Lake install Catkin Lake build, but it does build already. Anyway, let's do it again. Do I make a mistake somewhere? And I don't see anything. Mechatronic PI message generation, that was a problem last time. I just got to import some. And it says it seems to be alright. So once again, was run. Sometime executable. Now let's compare. And this seems to be quite alright, to be honest. So I do have a package, but I can't find an executable named Mechatronics PI. It is some kind of, let's say, typo. I don't think so. So if I do exactly the same thing as this robot PI, robot Pi, what is the difference? Perhaps back to square zero. Back to the start. Alright, and after some searching, I find one more hint, which I am not going to into so far that it has to do with computers. And then looking in the C note file, netlist in the text, I find a difference. In the robot Pi, I find this line, and this line was completely commented out in the Mechatronics package. Added to that, message runtime was missing, so now they are the same. So let's see if that indeed is the culprit. So in here, let's see what happens now. And it's still the same, regrettably. So this is alright now, and the message is alright. Captain packages package is alright. That's exactly the same now. So this is alright. Although here is an include which is commented out, but I guess that is not such a problem. Oh, don't really find anything else. And here I am at the bottom. And here I am at the bottom. So basically, they are the same right now. From here up. Of course, they are not exactly the same because there's a package list there, and this is only one message imported, and this has, well, basically also only one imported. But it is still the same. So what I'm going to do now, back to the root and back to make. See whatever that gives me. Not moving, and have to put this one. Now I have definitely changed something, and it failed. Depending on captain typo. Mate. a typing mistake. Yep. Almost at the end. Yep. And that will be it. Another try. And it also is done because of the camera feeds. Still fails because of a run dependency in the package XML fails. So how come that when I do it according to the tutorials, still things go wrong? So, conclusion, I'm moving things according to the tutorials apparently. Anyway, let's do it again. The discrepancies start building up, or seem to be building up, because now I'm looking at the package XML, and not only I have to add message generation here, it also turns out that this says run depend, while this for some reason says accept depend, or execute, or execute. Well, execute is more or less the same as run, but in command it can make a very big difference. So I've added it like it is here instead of copying exactly what it says here. So let's save and quit this one and go back to the directory of the workspace, and well, let's build again. See whatever happened this time. Yeah, one message, 0 services, that is correct. But that's not all what I like. 6 messages, 0 services. Yeah, alright. 6 messages? Could be. But now it says it is alright. Let's test that. Is it alright? Can I finally run it? Or does it go bad again? Yes. Could not find executable. So all my debugging attempts so far are without any result. And of course I'm not liking this. So let us test the other package again, because things should be working at all. Right, and then I have to run this one, go here, and run with it, I mean of course the publisher, and subscribing. So by testing this, I will make sure that on that part, hardware-wise and software-wise, nothing wrong happens. So, starting this one, starting here, there we go. Well, that may say more than enough. With the LED and that one. Alright, that works. What next? Interesting.
Alright, final part of this episode. Not very nice to do, but debugging is integral part of development. You can't do without. And no matter what I say, you will make typos, you will make mistakes, and therefore debugging is essential. And with this, well, this package runs not flawlessly, because if it had run flawlessly, it would have recognized the 4 other messages: FT sensor pi, message robot pi, another message robot pi, and FT photo transistor. It would have recognized them, it would have used them, and things made possible for a lot of nice ideas and things to do. Instead of that, I felt that I should start over with a new package, and that gives only problems so far. And the details that I show you give me quite a few question marks. Which leads to the nice question: what will happen next time? I don't know yet, we'll see. Anyway, thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment, much appreciated. You can also follow me on Twitter, retweet and like. Leave a comment. You can also follow me on Instagram. Like and leave a comment. Please donate to keep the videos coming to you. It takes energy and time and a lot of effort to make these videos, because after recording they have to be post-produced, and that takes time as well. Editing, so as called. You can also become a patron and have your name mentioned either just on my website or with the videos as well, depending on the pledge you make. Much appreciated as well. And this is of course going to be continued. So I'm happy that the GPIO is alright and that it was a piece of bad wiring. And let's once again make sure that things work the way they are supposed to work. That is to say, yep, that's it. Alright, once again, thank you for watching. Bye bye.